I've been working on PL/SQL since 1991, wrote a book in 1994, and ever since then I've been doing almost nothing but PL/SQL, writing it, writing about it, helping others leverage the PL/SQL language more successfully. As you can see on this page, I've got an email address. You feel free to contact me directly. Follow me on Twitter. Check out my blog. Check out my YouTube videos. Lots of ways to get information about PL/SQL, with more to come on the next slide. What I'm going to do is spend an hour sharing with you new features in Oracle PL/SQL in the 12c and 18c releases. And in fact, I'll start with 18c. So as I said, lots of resources for database developers. And what I'm going to do is actually use a number of these resources tonight, or mainly one of them, LiveSQL. So first of all, we do have a homepage for PL/SQL, oracle.com/PL/SQL. Check it out, resources on PL/SQL, the latest version, the latest features, etc. Check out our OTN, or Oracle Developer Community Forum, on SQL and PL/SQL. There's a blog from Bryn Llewellyn that you do not want to miss. Bryn Llewellyn is the PL/SQL product manager, so he's the guy who works directly with the development team. And his knowledge about the language and how to leverage it is far greater than mine. I'm sort of the popularizer of PL/SQL, and happy to do it, but he's the real thing. Oracle Learning Library has a lot of resources on everything having to do with Oracle technology, database, and not. And then let's get into my favorite websites when it comes to working with Oracle Database and PL/SQL. First of all, my favorite, because I'm very much involved in it, the Dev Gym. So the Oracle Dev Gym offers quizzes, classes, and workouts on PL/SQL, SQL, and just started a few weeks ago, Java, database design, logic, application express. It's a great way for you to take what you're learning by reading and watching videos and so on, and activating that knowledge by taking quizzes to reinforce your knowledge. Ask Tom, hopefully everybody knows about. AskTom.oracle.com is one of the premier question and answer forums on the internet for Oracle Database. And we've recently added a new feature called Office Hours. I'll show it to you in just a second. And here's the website we're going to be using a lot during this webcast, which is LiveSQL. LiveSQL offers a 24/7, that's not right, 24/7 access to the latest Oracle database, in this case now 18c. So you can write SQL, play around with SQL, write PL/SQL, you can access a code library, you can share your scripts with other people around the world. It's a great resource. You got to check it out, as you're going to see tonight, or my night anyway. And then there are a couple of great websites from non-Oracle people, especially Tim Hall and his fantastic OracleBase.com website, which offers just an incredible array of articles about Oracle technology for years now. Okay, so before I dive into all those new features, I'm going to take a look at those websites, familiarize you with them for a moment. So here's LiveSQL, livesql.oracle.com. And once you sign in, you'll have access to all sorts of great resources for working with SQL and PL/SQL. Let's sign in. Now, I've loaded up over 200 PL/SQL scripts onto the LiveSQL code library, and we're going to be using a fair amount of them tonight to demonstrate the 12c and 18c new features. It's more fun than running scripts in SQL Developer or just showing you code in slides. But you can come here and just click on the SQL worksheet and go to town. Start playing around with the SQL language. This is especially great for people who are new to these environments. So for example, I can say, show me everything you got in the employees table. Off we go. But as I said, so in addition to the scratch pad of just writing stuff and trying it out, you can go to home, do a search. For example, 18c. What have you got? We've got a whole bunch of stuff on 18c. So you can come here and just start to learn about and play around with the latest features. And as I'm about to do for the PL/SQL new features, you can also publish your own scripts. I won't go into all the details on the site, but if you're not familiar with LiveSQL, please do check it out immediately to leverage everything we're giving you from Oracle itself, and also what others are doing with the database and making available through the LiveSQL code library. Ask Tom, as you all know, is the #1 place to go on the internet. It even rivals Stack Overflow for the number of questions and the quality of the answers that you'll get. It was run by Tom Kite for about 15 years, and now 2 members of my team, Chris Saxon and Connor McDonald, are running this website along with Maria Colgan. And others are contributing as well. So we've got questions and answers flowing out of the site at a greater pace than you've seen for years and years. So do use it. Ask your questions here. Do search first. We've also added a great new feature called Office Hours. So the idea behind Office Hours is to open up this really big pipeline for communication between the developers at Oracle and the product managers and evangelists and yourselves. And I'm going to turn on my webcam, which I forgot to do. Hi, everybody. I've been waving my hands around and I thought you were seeing me. So now I'll keep it on for the rest of the intro and then probably turn it off when we go into the code. Anyway, Ask Tom office hours, free training, how-tos and Q&A with Oracle experts every month. Check out this lineup. We've got dozens of experts covering a wide variety of topics in Oracle database. So what you want to do is search for something you're interested in. For example, I really need to learn about JSON in the database. JSON in the database. So I click on it, scroll down in. I can read about the upcoming next session in which we're going to be talking about JSON in the database. You can go and look at previous sessions and watch the recordings. And most importantly, you can sign in and subscribe. I'll unsubscribe just to show you the button, subscribe. So then you'll get reminders about each session that's coming up. So sign up for PLSQL, for SQL, Ask Me Anything Database with Gerald Wenzel and Maria Colgan. Oracle Application Express, they've got hundreds of people showing up every couple of weeks to learn more about Application Express from the experts themselves and to answer your questions. So take advantage of Ask Tom office hours. And finally, before we get started, the Dev Gym, my favorite. It's something I've been working on since 2010 when we started it as the PLSQL Challenge. So the idea roughly behind the Dev Gym is that it's an active learning experience. It's great to buy books and read books, buy my books, read them, but it's a relatively passive experience. Even watching videos, you watch, information comes into your head, but you're not actually using it. So of course, you can't really learn how to write PLSQL code until you write it and really dive into the nitty gritty. But also another key technique in terms of being a good programmer is learning how to read code and understand what it's going to do. And that's what this website is great for. We have over 2,000 quizzes on SQL and PLSQL and database design and Application Express. And now we've just started up a new quiz on logic. On Java, jump into Java. So basically you come to the site, you can click on these different quizzes. These are the tournament quizzes. You can actually be ranked internationally and compete in annual championships for global ratings, or you can just play the quizzes to learn. We also offer workouts that combine quizzes with videos or articles, blog posts, or live SQL tutorials. And we've got a lot of predefined workouts. You can also build your own with a do-it-yourself workout. And we've got classes, a whole bunch of classes and lots more to come. So if you've got anybody new in the Oracle database world, tell them to check out the Database for Developers classes from Chris Saxon. The Foundations class and now the Next Level classes are a great way to get into Oracle database or general database concepts. Analytics SQL. If you've been wanting to get your head around window match and pattern matching and match recognize and all the different aspects of Analytics SQL, check out Connor's class. These are all on demand. Just go onto the site and take them. I've got a couple of classes on table functions and error management, and we'll have a new one opening up soon on using Python with Oracle. So lots of great resources here. We offer so much. This is all from the Applications Tools development team. So in addition to building the tools, we build these websites and we pack it full of information for you. Use it. You might hear that. That's my granddaughter. June, I'm working now. You have to go back upstairs, please. Thanks. I'll see you soon. That was fun. Okay, so let's talk about 12C and 18C new features for PLSQL. There's a lot of them. We packed a lot into 12C, and you'll see there are a couple of pages coming up. There's actually only one major feature into the first release of 18C, though there's another release that will be coming out relatively soon. So I'm going to cover that first. So in terms of the 12C new features, let's run through them. And as you'll see, there's a lot. So I'm not going to be going into much detail on any of those, but staying at a high level. Okay. So first of all, whitelisting with the AccessibleBy clause, you can actually say which programs can call other programs and whitelist, and basically the reverse being the blacklist. Nobody else will be able to use those programs, but the ones you've whitelisted for. Now we make PLSQL only data types available through the PLSQL to SQL interface. What that basically means is that when you're executing dynamic PLSQL, you can now pass native PLSQL types like record types, Booleans, collection types. As before, you could only use SQL specific types. We offer a couple of options for making it faster to run your functions from SQL. Util call stat package replaces or supersedes existing functions like dbms utility format call stack or format error stack. You can now return and display results. That's basically for Microsoft SQL Server migration and matching their functionality. We offer a number of enhancements around privilege management for program units, and specifically, essentially, CBAC, code-based access control. You can assign roles to program units and restrict what people can do based on those roles at runtime. Static expressions in place of literals allows you to, for example, stop hard coding the size of varchar2 variables to say 2000 or 32767. You can now mark elements for deprecation. So you can actually say this code shouldn't be used anymore. And at some point down the line, you can actually make it an error if people try to use those programs. PLScope, which is an amazing feature of the Oracle database that allows you to analyze your code in great detail, now analyzes SQL statements as well as PLSQL statements. You've got a lot of features around JSON for PLSQL object types, implemented through PLSQL object types. There's block code coverage, so you can get a sense of which parts of your code are being used and not used. Some enhancements to the hierarchical profiler, and some enhancements to DBMS SQL. These last three we're not going to really get into tonight. There's not much, I think, there that you're going to be likely to use, and I'd like to focus on those things that are most likely to meet your needs. Now, before I dive into this 12C feature, what I'm going to do is show you the 18C feature that you're going to like a lot. So let's go over to LiveSQL. So again, in LiveSQL, there's this code library with hundreds and hundreds of scripts. I've got about 210 myself just on PLSQL, and there are lots more. And at this point, you could just say, well, let's search on 18C and see what we've got. And I encourage you to just go exploring in LiveSQL. For example, the new polymorphic table function. It's a fantastic new feature. Got a couple of scripts on that. And this is what I want to show you, qualified expressions. So let's actually change my filter a little bit. Qualified expressions. We're going to take a look at qualified expressions for arrays and constructors. Now, you probably have heard of constructors, for records. Let's start with records first. Now, hopefully you've heard of the idea of a constructor function. A constructor function is a function that has the same name as an object type or a nested type. And it allows you to initialize that object type instance or the nested table or VArray instance to be either null or with some values. And that's great. That's great functionality. It means you don't have to write a whole bunch of code in your executable section to initialize these structures. But prior to 12C, you couldn't do the same thing for records and associative arrays. Now that's over. So for example, I've got a species record type that I've created, and I want to initialize it. And previous to 12.1, I would have to assign individual values in the executable section for each one of those attributes. But now I'm simply going to say, call my qualified expression. That's the name we give it in PLSQL. You can call it a constructor. It's really the same thing. And then you pass the values for the different attributes, the different fields of the record, and then it initializes elephant, the elephant record of that type. I've got my little display program. I can pass in the record. Notice I can also say as a default, I'm going to call that qualified expression instead of a default record. If you don't pass one in, I've got something I'll use instead. And as you can see, it'll display that information. So inline creation of a record type, creation of a record with those values, and then you can assign it to your variable either in the declaration section or in the executable section, where you can use it as a default value. Now you can't use it with %row type. So this is a user-defined record type. And the other kind of record types we've got, which are really nice, are records based on table rows. So I can say table %row type, but you cannot use the qualified expression syntax there. Sorry. So this fantastic new feature really only comes into play with user-defined record types. Let's go back to the library. And my favorite, even over those record types, is for associative arrays. So prior to 12.1, if I wanted to assign 55 to element 1 in my array and 555 into element 2, I would have to write individual assignments for each one of those different expressions, for each one of those different elements. Now I can simply say, use the same name as the type, call that function, that qualified expression, pass in the values that I want to assign. And I can use, no, I can't use. I have to always tell it which element to use. So notice if I try to say, well, this goes into 1, 2, and 3, and I don't specify it, It says named association syntax is required. So what I do is say, well, 1 gets 55, 2 gets 555, 3 gets 5555. And then I see those values. So inline assignment of an entire associative array. And it even works for string indexed arrays. So here's an example. Let's see, I've got a collection of records in this case where I'm calling the array the constructor or qualified expression for the record. And then I'm calling the qualified expression for the array. And for string indexed arrays as well. So now I'm indexing by varchar2. If this is new to you, if you have not done string indexing, you should definitely check it out. It's a very powerful feature in PLSQL. So now I can say my by string type, and the index element is not 1 or 2 or 3, but it's whatever string I want to give it. And the same syntax applies. Okay. So this is the big feature for usability improvements in 18C. I can now call qualified expressions or constructor functions for associative arrays, both integer and string indexed arrays. And also, if I go back to my library, pick up my records, also for record types, for user-defined record types. Okay, let's go back to the PowerPoint. So that's 18C. Back to 12C. Okay, so the AccessibleBy clause. Essentially, most of the core critical features of PLSQL are in place and ready for you to use. So what you're now seeing over the last couple of releases, 12C and 18C, is a fine-tuning of a lot of these features to improve your ability to manage your code, control access to your code, improve security around your code. AccessibleBy is a great example. So what you're essentially doing here is telling PLSQL which programs are allowed to use the other program. So I simply add AccessibleBy this package. And that means that if anybody else tries to use that package, you won't be able to. Let's take a look in LiveSQL. I'm in LiveSQL. I don't need to search for that. Let's search for AccessibleBy. So, well, actually, this is 12.2. We can look at a nuance of that in just a second, but let's look at the 12.1 first. So use AccessibleBy to create whitelists, right? So I've got my public package. Now, it used to be a really enormous package, and it became hard to manage. Thousands and thousands of lines, hundreds of subprograms. So I decided to break up that one big package body into multiple smaller packages that I could manage more easily, and multiple developers could work on more easily. It really is a private package. In other words, the only things that should use it are elements from my public package. But once I create a separate package spec, anybody writing code in my schema could start to work with this code. And I don't want that. I want it to be restricted so that only this guy can call stuff in this package. And this is how I do it. AccessibleBy, this public package. And then if I try to invoke this package, it works. So public package, do only this, says call those different private package subprograms. And it did it, this and that. But if I try to use it directly, so now I'm calling private package, not from public package, not even from another stored program unit, just in an anonymous block, it says, sorry, you don't have the privileges to access this object. And certainly if you have another stored program unit that tries to use this one, it's not going to work. So AccessibleBy gives you the opportunity to really think through the pathways of usage that you want to have in your code and put more controls around what can be done about it. Now, the key thing here, of course, that if you had code in multiple schemas, you can use grant executes to control who can call what. But this works even within the same schema. So you've got all the code in the single schema, which means anybody who can edit the code can basically access any of the program units. AccessibleBy gives you another level of control that says, I really only want this package, or you can have a comma delimited sequence to be accessible by it. Okay, and in 12.2, you got the enhanced option of being able to specify subprograms and different types. So it's accessible by this procedure, accessible by this trigger, or accessible by subprograms. So now even within a single package, I can specify accessibility for that individual subprogram. Good stuff. Time is flying by. Let's keep going. So PL/SQL only data types cross the PL/SQL to SQL interface. There are a number of aspects of this feature that are really cool. One of them is that I can now use the table clause with associative arrays. Essentially, I can have table functions that return associative arrays. I can also bind PL/SQL specific types like Booleans. So if I have dynamic SQL and I call a subprogram that has a Boolean parameter, prior to 12c, I would have had to create a wrapper around it to convert the Boolean to a string or a number, 1 or 0, y or n. Now I can pass Booleans natively in PL/SQL. Let's take a look. Go to my code library. Get rid of accessible. And let's see if I can find my script. Let's see. That's not going to work. Sorry, I should have had it sorted out already. Let's just do 12c and then PL/SQL. Here we go. Okay. So notice I've got, let's scroll down here. This looks like the wrong script. Okay, let's go over to my SQL developer install and show you some code because I couldn't find it fast enough. So bind Booleans. Let's make that code bigger. Oops. Come back, fonts. Okay. So notice I have this procedure, eat that, in my restaurant package. Make it spicy or not, Boolean. Now, prior to 12c, if you have a parameter like a Boolean or a record type or an associative array, these are types that are not known in the SQL layer. So if I tried to use it in PL/SQL, it simply wouldn't work. But now, inside an execute immediate statement or open for, I can execute my PL/SQL block. And notice I can pass in and out Boolean values. So essentially the thing to remember now is that in 12c and higher, if you want to execute dynamic PL/SQL blocks of code, you can now do it even if there are PL/SQL specific types that were formerly not allowed. So you don't have to worry about building so many of those wrappers. Now, in native SQL itself, you might still run into the issue. So the SQL layer still doesn't know what a Boolean is, but at least inside dynamic PL/SQL, you've got that advantage. And while we're here, let's find my associative array. So again, prior to 12c, if I tried to say select from table of an array, that would not work. But now I can say, for example, declare my variable based on an associative array type, assign an array to it, or populate the array. And then I can say select column value, that's the predefined column name, from the table operator of my happy family, which is defined as an index by collection or associative array. Prior to 12c, no way this would work. You can only do this with nested tables and view arrays. So now, even for associative arrays, which can be highly sparse, have all sorts of different interesting properties like negative indexes, you can now use the SQL operations against that collection by putting it inside the table clause. Cruising along. Optimizing function execution in SQL. So many times, one of the really nice things about the tight integration of SQL and PL/SQL is that you can call your own PL/SQL functions inside a SQL statement. You can essentially extend the SQL language with your own stuff, which is really nice. There are a lot of things to be concerned about when doing this. One of them, primarily, is performance. So when you call a PL/SQL function from a SQL statement, there's a context switch from SQL to PLSQL. And by the way, in PLSQL, when you execute a SQL statement, there's a switch to the SQL engine from the PLSQL engine. And that context switch is one of the major causes for performance degradation in our database operations. That's why, for example, we introduced for all and bulk collect back in 8i to reduce the number of context switches. But now we're talking about reducing the cost of each context switch. And there are two ways to do this. One is that we've extended the with statement, or the with clause of a SQL statement, that allows you to do inline tables or views and then basically do modular SQL construction based on them. You can actually use the with clause to define a function right inside a SQL statement. And we've got a new pragma, which is a command to the compiler called UDF, which says, hey, this is a user-defined function. I intend to use this function almost exclusively inside the SQL engine. Therefore, get it ready for me. Let's take a look, and then I'll explain a little bit more. So I'll go back over to my code library. Let's look for UDF. Okay, I guess I didn't put a script there. Let's go over to SQL Developer. So it's really quite simple. If you've got a function that you expect to be called almost all the time or all the time from a SQL statement and not inside PLSQL, you can simply add the pragma. And then when this code is compiled, when the PLSQL engine compiles this code, it basically says, okay, if you're going to want to run this from within SQL, there are some things we can do now rather than at runtime to improve the performance. So basically the cost of the switch is reduced because they take care of some of the work at compilation time and not runtime. The downside might be that if you call this function from PLSQL natively, it might run a little slower than it would otherwise because it's optimized for SQL execution. But you shouldn't see too much of a degradation. And again, the main thing is, if it's one of those functions that you're always using in SQL, just use the pragma and off you go. Now, I took out a couple of lines of code there just in case you weren't aware of what this is. This is called conditional compilation. I'm not going to talk about it in any great detail in the session, but it essentially allows you to do meta compilation commands. You can say, for example, what I want to include and exclude based on conditional statements. So if I want to include a UDF, it's set here to false, then this will not be included and the code will not have it in it. If I set it to true, then it will include the pragma UDF. So for example, if you're writing programs that need to run on multiple versions of Oracle database, then you can use conditional compilation to actually compile in different features and versions of your code based on the database version that it's running. Lots of different applications for conditional compilation. Do check it out. In this case, I was simply using it to turn on and off the UDF for some performance comparisons. I'm not going to get into that right now. Let's see what we've got around the with clause, though. See if we have anything in the code library. Oh, nothing there. Okay, let's stick with SQL Developer. Okay, so here's an example of actually creating a function inside a select statement. Pretty crazy stuff, right? So essentially the main motivation for doing this is if you have the same simple expressions or computations being executed multiple times in your SQL statement. Prior to this feature, if you wanted to avoid all the repetition, it might be very simple, but you still don't want the same logic appearing in 5 different places, maybe the same constant value, the constant literal. You would have to write a function inside your PLSQL stored objects, and then you would have to call those functions, and you'd have a context switch, and you'd have all the overhead of doing that. With the with function, you can declare the function directly inside your SQL statement, and then the cost of that context switch, once again, is reduced. Now, you can think of them as being on par performance-wise between the with function and the UDF, but they're quite different things. So the UDF is a more general piece of functionality that allows you to mark any function you've created in the backend in your stored object set to be optimized for execution in SQL. In this case, you're actually taking the code out of your stored object code base and putting it into the SQL statement. So you really wouldn't want to put anything really complex in here. You'd really want to keep it to small, simple expressions. But it could help clean up your code. And another great use case for the with function is if you're working in a read-only database. Let's say you've got an archive database and you can't create PLSQL program units, functions, packages, whatever. In that case, you can, in line of the select statement itself, create those functions and then utilize them inside that select. the util call stack package. Okay, now this has to do with error management and also tracing. Here's what I'm hoping. Whenever you are handling errors in your code, you have a generic error logger. For example, there's a utility called Logger on GitHub that you can download and use that allows you to log the error. And when it logs the error, you pass in information about your current program state, for example, the values of variables, of parameters, and so on. But inside that generic reusable piece of code, it gathers all the information it can from the system and save it. And some of the primary pieces of information that you want to get from the system are, how did I get here, which has been available since 9i, 10g, through the dbms utility format call stack. What's the error message? Well, you can use SQL error message, but format error stack, dbms utility format error stack, is a bit more reliable and less likely to truncate a long error stack. And my favorite of all, on what line was my error raised? Where was the error raised? And this was introduced in 10G release 2, format error backtrace. So your generic logging utility should call these procedures. If you do not have this already, if you do not have a generic error management package, I encourage you right now to go out to your browser, type logger, GitHub. You'll find the logger project. And this will basically do everything you want, both for execution tracing and for error logging, and it's more sophisticated than something you're likely to build. So download this and use it. And then you'll have that generic capability, and all these functions are built in for you. You won't even have to think about them. Now, so that being said, there have been a number of problems and complaints and requests for enhancement for these functions. For example, the format call stack program will not show you the names of subprograms in the package. It will just show you the name of the package. And in general, it was a rather unwieldy implementation. You just get this big string, and then you have to deal with that string yourself. With the util call stack package, it gives you a very granular access to the API, or it gives you an API with granular access to the elements in the stack. You can actually write code to read through the stack and then print out the ones you want or save the ones you want and so on. And then you can get things like the full names of the subprogram. Let's take a look in LiveSQL. So here's one of several scripts that I wrote. And in general, you can see what I'm going to do is call format call stack. And then I'll take advantage of some of the utilities in the util call stack package. For example, concatenate subprogram will give me the fully qualified name of the element that's being executed at that time. And you can see that here. So I've created this little package body that calls proc1. Notice it's a subprogram with a nested subprogram inside of it. And when I call that program, here's the output I get. Here's the traditional call stack using format call stack. Now, this very long stack here is mostly because it's running inside LiveSQL, which is built on Apex, which is built on dynamic SQL. It's pretty complicated, but here's the part that we care about. So here's the name of my subprogram, and here's my nested subprogram, as you can see here as well. So that's one of the advantages with util call stack, is you get all the way down to the nested subprogram name. There's also backtrace information and format error stack information. So basically, if you want to, you could stop using these functions and instead use util call stack. And to make it easier for you to do that, one of the scripts you'll find on LiveSQL is an emulator of those three functions. So this is something I built a few months ago. My util call stack, format call stack, error stack, and error backtrace. And it basically does the work of iterating through the API for util call stack, getting the owner, the unit line, concatenate subprogram, etc. So you might just want to look at this utility to get a better understanding of how to use the API. But for the most part, you're just going to want to call these functions, grab the strings, throw them in your log, and look at it later. But we now offer a number of different options, and this will definitely give you the most to work with. Returning, displaying results, that's in dbms SQL. I don't think there's much that we really need to go on about this. Basically, it will allow you to display immediately the results in your environment. In Transact SQL, you can run a procedure that has a select statement in it, and it will simply be the same thing as like running the select statement. So we've added that same capability in DBMS SQL. So if you are looking at a situation where you're migrating code from TSQL, Transact SQL and SQL Server, into Oracle, take a look at these new features in DBMS SQL. This is a nice little thing. Static expressions in place of literals. So for a long time, you might have said, well, if I need to declare the biggest string size possible. So I'm going to declare it to be 32,767. Some people might even argue, why not declare everything as varchar2 32,767? By the way, it won't give you any kind of memory issues, but it looks really weird. You don't want to do that. The problem, of course, the biggest problem with declaring something like varchar2 32,767 is that we might at some point extend the maximum size of a varchar2. Maybe someday there'll be no difference between varchar2s and clobs, 4 gig, 12 gig, whatever it is, really big. So if you hard code what you think will always be the maximum size, that could turn out to be a constraint in your application later. It would be much better to make this a variable value, but up until 12c, you couldn't do that. Now in 12c, you can use what are called static expressions, which means it's an expression, a literal or a combination of literals and operators that can be evaluated at compile time. That's what static generally refers to, whereas dynamic refers to runtime. So you can now use static expressions in place of those hard-coded literal values. And we even offer some predefined constants. So Oracle max name length is the maximum length of a name. And we're going to add 2 for it to the 2 dots. And I can say a qualified variable is 2 of those, because you can have schema or package dot subprogram or procedure dot variable and so on. So I can now use this pre-built, this predefined constant as my maximum length, and then construct more complex expressions for if I want to support qualified variable names or not. Let's take a look in LiveSQL. So I can say my maximum length, just to keep it really simple, is 32,767. And whenever I declare anything based on varchar2s and I want the maximum length, I can now use that constant. That is definitely a static expression. Here's another static expression. So in my nested block or my anonymous block, I can use that constant and I can say, well, I only want half of the normal size for whatever reason. You can build whatever expressions you want. But you should no longer have to hard code these limits into your code. You can define them in one package, and then you can update that one package as things change either in the Oracle database or in your own environment. For example, the maximum precision that you want to manage for currencies. And then you can change it in one place, recompile your code, and those new limitations will be applied in the newly compiled code. One of our favorites for many, many years, people have been asking, why do you have this limit of 30 characters for your names? And I got to say that sometimes it's frustrating to hit that limit and have to shave down from 32 to 29 or 28 to make it fit and lose a little bit of readability. But I think there's also some element of that constraint giving us the motivation to think creatively and very concisely about how to name our variables. But no more. Now your names can go all the way up to 128. Really, really big strings. But give some thought to how you take advantage of this new feature. First of all, the main reason we did this was not so that you no longer, you could make these massive names of things that would be virtually unreadable. But when we're migrating from other databases that have different maximum name lengths, we ran into problems. What do you do with that name if a larger name is supported, let's say in SQL Server, or even outside another non-relational database entirely? What do you do with those long names? Then you have to figure out a way to cut them down. Also, multi-byte character sets could easily result in names that are much longer. To me, the main advantage and the reason I've really benefited from this, the removal of the limitation of 30 bytes, is that now if I have that name that is exactly what it should be, that really accurately describes the variable or the program that I'm creating, and it goes to 32 characters, I don't have to compromise. I don't have to come up with abbreviations or prefixes that make it harder to understand my code, I've got my 32, my 35 characters, and we're good. But I've got to say, if you're going to go and start creating things with like 60, 70, 80 character names, chances are you're just going to be destroying the readability of your code. Goodbye tiny SQL varchar2. So for years, the maximum size of a varchar2 column was 4,000, while in PLSQL, it was 32,767. Another source of frustration and really unnecessary friction between these two tightly linked languages. So if I had a 32K string, I'd have to store it as a clob. And there's overhead related to clobs that I didn't really want. I don't have it in PLSQL. Why do I have to have it in SQL? So that's no longer the case. Now what you have to do is get your DBA to agree to set the maximum string size parameter of your database to extended. One-time operation. Once you do it, you can't go back. I'm not sure why you'd want to. But if your max string size is set to extended, then varchar2s will be supported up to 32K in relational, in tables, column types, and so forth. All right, marking code is deprecated. Well, I showed you the dev gem before. We started writing the dev gem in 2010. So it's now 2018. The code base is something like 75 or 80,000 lines long. And believe me, there's dead code in there. There's code we shouldn't be using. Now, of course, what we should do is be very rigorous about finding all the old versions of the code or all the old references, getting rid of them, refactoring our code. But sometimes you don't have time to do that. So what you can do right now, at least, is in 12.2, in 12.1 and higher, you can, in 12.2, you can now mark a subprogram as being deprecated, or you can mark the whole package as being deprecated. Now, this won't do anything by itself. You can say everything's deprecated. You can still, people will still be able to use the code, but you're putting a marker in place that this is code that should not be used if anybody comes along and looks. And also you can provide a message that will be displayed, and I'll show you how and when it will be displayed if somebody tries to use it. So there are two parts of using this feature. One is, as I'd mentioned, to simply mark elements as being deprecated. And the other part of it is to use compile time warnings to identify where deprecated code is being used. And if you mark certain error compile time warnings as errors, you can actually stop people from using deprecated code. Before we go on, let's take a look at LiveSQL. So let's search for deprecated. Come on. There we go. All right. So here I'm going to say, deprecate this package. I don't want you using this package. But like I say, it doesn't mean that you can't use it. However, if you do have warnings turned on, so here's my warning. I define this as a deprecated program, and it says this has been deprecated. So now I've got a PLW. Whenever I compile this code, it's going to tell me, you just compiled a deprecated unit. Okay, big deal. And then if I want to use the deprecated program, I can. So here's a create or replace this procedure. I compile my reference to my deprecated program unit, and it works. I don't get any errors, but I do get a warning, PLW 6020. I've got a reference to a deprecated entity. So it notifies me if I've got compile time warnings turned on, which you definitely should, and I'll show you how to do that in SQL Developer in just a second. It will warn you, you'll get actually a report in your compilation that you used a deprecated subprogram or package. And if you want to go take it a step further, so for example, you've been working on setting up all your deprecations, now you're sure that nobody should be using the deprecated code anymore, and you want to be sure of that, I can now say alter session, set warnings, and then error. All these deprecated related warnings are now to be treated as PLSQL errors. So now notice, first of all, if I simply try to compile the package that is marked as being deprecated, it says PLS, not PLW. It's not a warning. It's an error. You tried to compile a deprecated program. It's not happening. It actually fails. Now, you probably don't want to say, you probably don't want to set 6019 as an error itself, because that's just the definition of the deprecated program. So what I would do is set your warnings to be erroring out 20, 21, and 22. And then if I try to use, first of all, I can compile my package, and it's created, so it doesn't stop me anymore. But if I try to use that package, now that reference is invalid. You got a reference to a deprecated entity, and notice it tells me the message, use package.newproc instead. So there are two lessons to learn here. One is that the deprecate pragma is very handy for giving you some additional control and self-documentation in your code base to say, don't use this anymore, please don't use it anymore. And you can keep it as a request. But if you take advantage of compile time warnings, and I know a lot of developers are not aware of this, so let's take a look. If you go to Oracle SQL Developer, Preferences, and I look for Compile, this is the PLSQL compiler window. I can turn on all warnings, so I enable all warnings. I can also set to errors severe and performance. I want to make sure that if there are any performance warnings, they error out. I have to optimize my code fully. So they give you a nice little interface here to set up your PLSQL compiler options, including optimization level and PL scope. But you can also write specific code to force errors on individual warnings. And that's where this comes in really handy. Okay. So you can use the deprecation pragma, and then when you're ready, you can actually use the compile time warning subsystem to force those into errors, or simply to give you reports on them and get better understanding about how your code works, how it's supposed to work. Cruising right along. So let's take a look at some privilege-related features that have to do with definer and invoker rights. And I don't have a lot of time to get into the details of it, but quite briefly, definer rights means that when you compile a stored program, it's compiled with certain privileges. And when I let you execute my program, you're running with my privileges. When you execute a stored program, it runs under the privileges of the definer of the program. And that's a really powerful technique for controlling access to underlying program units or data structures. Invoker rights, if you choose that approach, means that at runtime, Oracle will take a look at who's trying to run the code, and the privileges of the person running the code, the invoker of the code, will be used to determine what references are, how you resolve references to database objects in the subprograms, and therefore what you can do. And I'm going to skip over some of this. We just don't have time. So here's the big thing. In 12c, you can now grant program units. You can grant roles to program units. And the basic idea here is to not give any privileges to anyone running code beyond exactly what they need and no more. It's the least privileges principle. It's called code-based access control. You might want to look up CBAC. There are a number of great blogs and articles about this out there in the documentation as well. But essentially, it will give you that ability to very tightly control who can access what in your code base, not based on schemas, not based on roles, which are powerful, but also not granular enough, but down to individual program units. And I'm just going to keep on going because we don't have a whole lot of time left. Also in 12c, we tied up a loose end when it came to views. So with an invoker rights program, let's say I have a function that's called invoker that is defined with invoker rights. That means that when you call my function, Oracle will check to see what your privileges are to resolve references to tables and other database objects inside that function. But if a view used the function, then it would always do definer rights. It wouldn't honor the invoker rights definition. Now you can use bequeath to get around that problem. Let's see if I've got a script on that one. Oh, okay. Okay. I've got one here. So now when you create a function, so here's an example of an invoker rights function. I define my function. Auth ID is current user instead of definer. And that means that when you run this function, I own it, you run it. When you run this function, it doesn't matter if I own a table called C12emps. The question is, do you have a table called C12emps, and what is it? Or do you have a reference or privileges on a table called C12emps? So at runtime, it resolves the reference to that table, no matter what the reference was resolved to at compile time. But if I call it inside a view, if I call this function inside a view, then that invoker rights will not be honored. So what I need to do is, in that view definition, add bequeath current user, and that passes on the current user into the function, and now it will now operate correctly as an invoker rights function. This is another nuance around privilege management, but we're going to be really short on time. So I'm going to kind of skip over it. You can basically override the ability to inherit any privileges when you're using invoker rights. So instead of inheriting things from the definer, instead of inheriting them, you can actually trim down what they can do and for example, leave it only with code-based access control and specific granting of privileges via roles. So there's a lot more, and there's a few more that I'm going to touch on, even though they're not in this PowerPoint. And the main thing I want to talk about is PL scope. So let's take a quick look over there. We'll just go live in Live SQL. So PL scope. PL scope, if you haven't heard about it or used it before, is something you definitely want to check out. Basically, if I say turn on the gathering of identifier information, set my PL scope settings to identifiers all, then whenever your code is compiled, the compiler will gather information about all the named elements in your program, variables, constants, subprograms, views, and so on. And then you can run queries against those underlying data dictionary views to get information about the structure of your code and all sorts of information. For example, find all the lines in my program where a variable is modified, not where it appears, but where it's modified. So you can see that there are different types. For example, assignment. That means that that's where this constant is defined a value. Reference, declaration, definition, etc. So PL scope, in a nutshell, gives you a tremendous amount of resources. It gives you a tremendous amount of ability to analyze your code and get answers to all sorts of questions. We don't have time now to go into the details of it, but I encourage you to check out both the scripts on Live SQL, and there are a lot of PL scope scripts, as you can see here. Lots and lots here. You can also go to my blog, Stephen Feuerstein on PL SQL. I just actually published a blog post called the PL SQL Resource Center, and it has a list of all the different primary resources, the documentation, Live SQL scripts, and also a really fantastic utility built by Philippe Salzberg that will help you use PL scope more effectively. There are helper programs inside Live SQL. For example, I've got a whole helper package here, but his utility is way better than my stuff. So check out PL scope. It'll give you an ability to analyze your code like never before. Support for JSON and PL SQL. So 12c gives you an enormous boost in terms of capabilities of using JSON and manipulating JSON in the database. In 12.1, the focus was on SQL manipulation, selecting JSON documents out, querying through the contents of JSON documents. And again, you'll find lots and lots of resources on Live SQL for that. In particular, a tutorial. Let me just point this out to you. So SQL JSON features in database 12.2. This is a very extensive tutorial that runs through all sorts of features of using JSON in the database. And I encourage you to check it out. And the tutorials in Live SQL are fantastic. As you run through this, read the code, read the explanations, and read the code, you simply click on Insert into Editor and then run the code. And it sets everything up for you. And then you can start playing around and learning how this technology works. So lots of features in the code library for JSON. And what you'll find are some scripts here that I wrote for object types, for PL SQL manipulation. Let's see. So just to give you a little bit of an example, since we are about to run out of time. So in 12.1, you could use SQL statements to get information out of a JSON document, also to insert JSON documents into the database. And there's the check constraint is JSON. Tremendous amounts of functionality there. Check it out. In 12.1, what was missing was the ability to modify JSON documents. Essentially, and it's still true in 12.2, you'd have to read the string out, make changes to it, push it back in. Now in 12.1, the way you could make changes was either directly manipulating the text of the string or using some third-party or external libraries, for example, Apex JSON, a part of Application Express, or PLJSON, a third-party utility, to manipulate the JSON document in an intelligent way. In 12.2, we've added a number of object types, so it's part of the object relational model of PLSQL. We've added a number of object types, JSON object T, JSON array T, JSON element T, and so on, that allows you to manipulate these JSON documents in a much higher level abstract fashion. So for example, here's a very simple JSON document, name value pair. I parse it into an object type, and then I can call methods like getString to display the string. Here's something a little bit more interesting. So I can take this JSON document, parse it into my hierarchical structure inside as based on my object type. And then I can call getKeys, and that gets my individual key values out of that. And then I can display them or whatever else I need to do. So what you'll find are a number of examples in LiveSQL that run through all of this stuff. And the reason, by the way, I'm showing you all this stuff in LiveSQL is we've got an hour. I'm already out of time. And there's a lot more we could talk about, a lot more I could show you. But you can only get so much into your head at once. And the main thing is afterwards, where do you go to get answers to your questions, to explore this stuff more fully? And the answer is it's really easy. Go to LiveSQL, go to the code library, search around. Go to DevGym and search around as well. I could say, well, I want to find out more about For All. You'll find all the quizzes and workouts and classes. Go to Ask Tom and search the questions. So this kind of presentation should just be the very starting point of your search and exploration into these different new features and what you can do with them. There's only so much we can cover in a webcast, but the online resources for you are tremendous. And I hope you will take full advantage of them. Well, that about covers it. I won't get into block code coverage, et cetera, but briefly to say that with block code coverage, we built an API similar to the profiler that when you run your code, we'll keep track of which lines of code were executed and not. And then hopefully you'll see this appearing in the various IDEs like SQL Developer in the future, so you can actually see a display of your code coverage and get a number. Do I have 80% code coverage, 60% code coverage? So when you run your automated tests using UTPL-SQL or some other utility, you'll actually also be able to find out how much of your code you've covered with your tests. So hopefully you get the clear idea that there's a lot of energy and a lot of effort going into enhancing PL-SQL, making it a better environment for you to develop really high quality code. These are days in which there's a more and more of a push to take logic out of the database and push it out into the front level tier, the application tier in JavaScript or other languages. And I think we should all advocate very strongly in our organizations that the more logic you put inside the database when it's connected to manipulating data, the more efficient, the more secure, the more maintainable your applications will be. And the PL-SQL development team is making sure that we're giving you the features to make that as easy as possible for you to do in a productive way so that you can help your UI developers be more successful themselves. And if you can work with your UI developers in a partnership so that they can ask you for essentially APIs to the data and APIs to the business logic, and you can provide them for them even through REST with Oracle REST Data Service, ORDS, you've got a great way to let them concentrate on all their fantastic, cool UI design and leave you to do that backend work that you know how to do well, and you can write the right SQL and the optimized SQL and the right PL-SQL APIs. And you'll both be able to succeed much more than ever before. All right, so that's the end of my presentation. Let's see, I'm going to jump over to chat and see if, whoa, with infinite windows, and see if we've got some questions here I should answer. Let's see. I don't see anything yet, so I'll stand for a moment or two, see if anybody has any questions. But like I say, the main way to get your questions answered is to go to LiveSQL and go exploring, and go to the DevGym and go exploring, and so on. All right, I think that'll do it then. So thanks very much for joining me. I hope you're making great use of PL-SQL and SQL, and please continue to do so for years to come. Thanks very much.